Hello everyone, we want to talk about modeling with variation in this video. You have two types of variation. You have direct variation and inverse variation, and it's a different formula used for each of them. You do need to know the formula, so I'm going to highlight it for you right here. If you have direct variation, then the formula is y equals kx to the n power. This means y varies directly with the nth power of x. Okay, so it's going to say in the problem probably that y varies directly. There are also problems that exist where you have to decide if it's direct variation or inverse variation, also called indirect variation. But the main thing is this, think of it this way. So notice something right here. Think of it this way. If a value rises and makes the other value rise as well, this is direct variation. So if you're comparing two values, if one value goes up, then that makes the other value go up. Okay? So for example, in the middle of what we're dealing with right now, if the value of the number of coronavirus cases goes up, then the death rate from coronavirus goes up. You with me? So they are directly related to each other. And I've got some more examples here. If the sales increase, then earnings increase, right? So if the sales at a particular store goes up, then the earnings that store makes should go up as well. Or the number of hours you work goes up, then your paycheck goes up. Now it's easier for me to say they both go up. I could also say they both go down. So for example, and especially in these day and times, if the number of hours you work goes down, then your paycheck goes down as well. The point is, it's the same direction. If one goes up, the other goes up, or if one goes down, the other goes down. The speed of your car and the distance traveled. So the faster you drive, the farther you drive, or the slower you drive, the shorter you drive, right? Those are directly related to each other. Another example, weight on a spring and the distance the spring stretches. Imagine a spring you're just holding in your hand, and you put some weight on the end of it. The heavier the weight, or the more the weight, the more the spring stretches. I can't say spring today. The more the spring stretches out. Okay, and the last example, not the only, but the last example, the more often in-person socializing, the higher risk of getting the virus, right? So the social distancing we have going on, if you do the opposite, if you socialize, then the higher the risk of getting a virus. All right, so those are all directly related. Now let's do some problems and see if we can use that information to actually solve a problem. Actually, I lied to you. Let's talk about inverse variation, also called direct variation, before I move on. So the difference. Inverse variation, it says if x and y are related by y equals k over x to the n. Now look, direct variation, let me go back a screen. Look, there's direct variation, y equals k times x to the n. But on the other hand, if you divide by x to the n, that is inverse variation. The k is called constant of variation in both situations, okay? Inverse variation, I want you to think this way. So right here, think this way. If y value rises and makes the other value fall, this is inverse variation. And I have some examples. So for example, the number of people working a job, the more people that show up, the less time the job takes. Right? So if it takes one person 2 hours to mow a yard, it might take two people, how long did I say the first one? An hour to mow the yard. Okay? So the more people that are doing the job, the less time it takes. Those are inversely related. One goes up, the other goes down. Or the speed that you drive somewhere, the less time it takes to get there. That makes sense, right? So if you drive to Montgomery going, 50 miles per hour, versus driving to Montgomery going 70 miles per hour, the faster you go, the less time it takes to get to Montgomery. Okay? Third example, the number of people that share an item, the amount each person will get. So if you have more people sharing your pizza, the smaller the piece you're going to get. The more people sharing your birthday cake, the smaller the piece everybody's going to get if you share evenly, right? How about the cost of gas? If the price of gas goes up, the amount of leisure travel goes down. You can't afford to travel anymore. So if the cost goes up, the amount of travel goes down. And the last one, the percentage of social distancing a person adheres to, the chances of contracting a community virus. So if the social distancing you do increases, the chance of catching the virus decreases. You see what's on my mind. Okay, and then finally, joint variation is more than one direct variation. I didn't write the word direct here, but really joint variation you consider as more than one direct variation. But you'll see it in action. Now I think I finally want to do some problems. So our first example A, it says set up and solve the following variation problems. So there's a setup where you come up with just an equation and then you solve. Okay, so here we go. We're going to do setup to start with. Now what's very important is this information right here varies directly. You got to know that, or you got to be given enough information to find that out before you can do anything. But a lot of them just say it varies directly. So the quantity y, so I write y equals, varies directly with the square of x. So first of all, what does the square of x mean? It means x squared. And since it varies directly, we do k times x squared. If it said varies inversely, you would do k over x squared. So we would divide. So directly you multiply, and inversely you divide. And then you plug in your information. Now we're still trying to come up with a formula, okay? So it says if y is 75, so I'm going to remove the y and replace it with 75. The k we don't know. By the way, that's your goal. Your goal is to find k. So goal here is solve for k. Now that's not going to be the last thing we have to do, but the goal right now is to solve for k. So if y is 75, when x is 5. So 5, and remember the squared is part of the formula. So that's enough to solve for k. So 75 is equal to k times 5 squared is 25, which is really 25k, right? If I solve for k, I'm going to divide both sides by 25, and I get k is equal to 75 divided by 25 is 3, which means the equation, remember the first step is to find the equation. Some homework, by the way, asks you for the equation only. And in that case, the equation is y equals 3 is my k, and I leave the x squared. So that is your formula. Set up, that's the setup part. Now the solve part, I'm going to do in a different color. So it says, find y when x is 4. So I'm back to my formula, y is equal to 3x squared. And when x is 4, I'm just going to plug in 4 in. So 4 squared. Now y'all, order of operations, I can't multiply 3 times 4 is 12. That's not right. Remember, I have to do exponents first. So y is equal to 3 times 16. And we know 3 times 16 is 48. So my final answer is 48. So if they want an equation, we were done right here. Basically, your goal is to set up the right formula. So that is this first step. Plug in the information. That's the next step, and solve for k. And that gives you the formula. And then, if they give you more information, like find something, then you have to plug that value into your formula to find the final answer, which again, the final answer in this problem is 48. So let's try it again. All right, so a quantity y varies inversely, very important, varies inversely with the square of x. If y is 6 when x is 4, find y when x is 5. Okay, so first of all, we've got to write the right formula down. So that's quantity y. It's always going to have a k. That k is always going to be up top. The inversely means we divide by, notice it says the square of x again, so I put x squared. And y'all, it's not always x squared. Sometimes it's just plain old x. Sometimes it's x to the third, x to the fourth, x to the fifth. These last two just happen to be x squared. So that handles, first of all, the varies inversely part. The next line is this part where we find out what k is. So if we substitute y is equal to 6, we don't know k, and x is equal to 4, don't forget the square, and solve for k. Okay, so now our goal is to find k. So 6 equals k over 16, Now, to solve for k, I multiply both sides by 16. And 16 times 6, I'm going to go to my trusty calculator. That gives me 96. So 96 is k. So my formula, and you will always have to come up with a formula. These first steps are required 100% of the time. That's y equals 96 over x squared. That is my formula. Sometimes that's all you have to do. But this problem continues and says find y when x is 5. So y is equal to 96, x is 5, so that's over 5 squared. So y is equal to 96, 5 squared is 25. You would reduce this to lowest terms if you could, but 96 and 25 don't have any common factors, so that's my answer. I found y when x is 5, and it is 96 over 25. Don't be nervous if you get fractions, it happens. Alright, x varies directly with the square of y. Something happened to my highlighter. X varies directly with the square of y and inversely with z. Uh-oh. We have both, right? Can we do that? Sure can. So first of all, it says x varies. So x equals. That's how that starts. Directly. So we know we have a k in here. I'm going to go ahead and put the k down here. Directly means you multiply by something. So it varies directly with the square of y. The square of y is y squared. But inversely with z, so we divide by z. Directly means you multiply. Inversely means you divide. The k is always in the numerator. And what comes before the word varies is your x equals or y equals, whatever the problem is. Now the next step is always the same. You're given some bit of information to find out what k is. You can't do anything until you know what k is. So if x is 50, and it says y is 5, so I'm going to do 5 squared, and z is 3. There we go. I just plugged in everything that was written right over here. X is 50, y is 5, z is 3. Then I'm going to solve for k. So I have 50 equals k times 25 over 3. Now to solve for k, I'm going to multiply by 3 over 25 on both sides. You know how to do that, because all that happens, and that gives you k all by itself. Now, if you wanted to do that separately by multiplying both sides by 3 and then divide by 25, that's certainly fine. The 25 and the 50, leave it 2 times 3 is 6. Plug that in the calculator, I promise you'll get 6. Okay? So, my formula, right, because sometimes it just asks you for the formula, is x is equal to, my k is 6, y squared over z. That absolutely has to be done no matter what. Now, if there's more to the problem, like out here, it says find x when y is 10 and z is 25, you just plug into your just found formula. So you have x is equal to 6, y squared is 10 squared, over z is 25. So that's 6 times 100 over 25. Now, you can go straight to your calculator if you want. I'm just going to go 25 goes in 104 times. 6 times 4 is 24. So the final answer to that problem is 24. Hey, this isn't bad, is it? I know it's word problems and you know you want to throw up, but this isn't bad. You can do this, okay? Okay, here's your challenge. Notice this says write an equation. So this is just the formula. All right? So pause it. Pause it now. Don't let me keep going. Pause it and work this out. All right, did you do it? Are you back? Here we go. So it says write an equation describing the relationship. Y varies. That means that y equals directly. Okay? So we know what we got here. In my red, I'm going to say y equals k. That's always the case. This variable may change to a different letter, but it's going to be whatever letter varies is equals and then k. Now the directly part means we multiply as the square root of x. You know how to write that. That's the square root of x. Now there you go. Now we got to find k, always the next step. So use the information to set up your general equation or your formula and then plug in the stuff they suggest. That's going to find k for you. So it says when x is 81, y is 36. So I'm going to say 36 is equal to k square root of 81. I'm going to solve for k. So 36 is k square root of 81 is 9. To get k by itself, I'm going to divide both sides by 9. 36 divided by 9 is 4. All right, now I got k, but I still don't have an equation. So I've got to take that 4 and plug him in right back up here in the k. So my final answer is y equals 4 square root of x. That is my equation that describes the relationship. Now the other problems that we have done, we had more after this where we would plug in, would find y, say if x is equal to 25, and we'd have another step to do. But if it's just wants you to write an equation, you're done once you find k and plug it back in. Okay. I challenge you to pause again. Pause, read this thing through, tell me what your equation is. Go. So you're back. That was fast. Write an equation describing the relationship. So y varies directly. So y varies directly as the cube root of x. That's where I've got to start. So I write y equals, that's my y equals, always k. That's where you start. Because it says varies directly, that means I multiply cube root of x. Y'all know what that guy is. That's the cube root of x, right? Now my next step is to solve for k. So they're going to give me enough information where I can figure out what that constant of variation is. Remember, k is called the constant of variation. And it's always in the numerator, whether it's direct or inverse. So they tell me that x is 64 and y is 20. So I remove the y and replace it with 20. I remove the x and replace it with 64. And then I solve for k. So 20 is equal to k, the cube root of 64. Y'all know that 4 times 4 times 4 is 64. So there we go, is 4. To get the k by itself, I'm going to divide each of these sides by 4. And so I get k is equal to 5. So that's y is equal to 5 cubed root of x. That is my equation or my formula. If they wanted us to find y given a certain x, I would carry on. But when it says write an equation, I am done with that problem. So I trust you're going to pause it and try this. And now that you're back, we want to write an equation describing the relationship. So this time, again, they're only asking for an equation. So y varies inversely as the cube of x. Okay, so I've got y equals k. It's always where you start with whatever variable they say varies. You write that first. Varies, think equals, and then k. And then you need the inverse to tell you divide by the cube of x. What's the cube of x? X to the third. All right. Then they go on to say when x is 3 and y is 2. So y is 2. We don't know k. We're trying to find it. And x is 3 to the third. So now I have 2 is equal to k. We know 3 to the third is 27. 3 times 3 is 9 times 3 is 27. I multiply both sides by 27 to solve for k. So twice 27 is, what, 54 is equal to k. So my equation is y is equal to 54 divided by x to the third. Now, sometimes they want more after that, but once it says it wants the equation, really all you're doing is the setup, solving for k, and you come up with the equation. Right? And then write an equation, and notice it says y varies jointly as the square of x and the cube of z and the square root of w. Wow, that's a lot, right? Y varies jointly as the square of x, the cube of z, and the square of w. Jointly just means you've got more than one, and it's all multiplication. So don't let that bother you. We're just going to write that out. It's all direct. Jointly just means more than one direct. So I've got y, because it says y varies, equals. Think about that as the varies part. You got to have a k. Don't forget the k. That's the relationship of the constant of variation. Now, jointly, again, multiplication. The square of x, so that's x squared. The cube of z, so that's the cubed root of z. No, the cube, not the cube root. The cube of z. If you paused and are doing that, don't freak out just yet. You're right. It's the cube of z, so x to the third. So the square of x is x squared. The cube of z, not cube root, not square root. Square means to the second power. Cube means to the third power. And the square root of w, that one is under a radical. There we go. There it is. Now, they give us a bunch of stuff to plug in. When x is 1, z is 2, w is 9, and y is 36. So I have 36. K is the goal. We want to solve for k. X squared, so 1 squared. I've got letter issues too. Point is the square of x, the cube of z. Goodness gracious, I'm losing it. Again, still don't freak out yet. There we go. The cube of z and the square root of w. Now it's right. So 1 squared, the cube of z. So z, they said, was 2. So it's 2 to the third. And then the square root of w, and w is 9. So the square root of 9. There we go. So I have 36 is equal to k. 1 squared is 1. 2 to the third is 8. And the square root of 9 is 3. Now, simplify this side before you do anything. So 36 is equal to k times 1 times 8 times 3 is 24. Got to get the k by itself, so I divide both sides by 24. So basically 36 over 24 is equal to k. I reduce k to lowest terms. 36 and 24 both divide by 12, don't they? So 36 divided by 12 is 3. 24 divided by 12 is 2. Now don't stop there. I don't think I've ever seen anything that just asks for k only. If it asks for the constant of variation, we'd be done, but it usually asks for an equation. So y is equal to the 3 halves x squared z to the third square root of w. And then there is our equation. All right, got another problem. Pause it, see what you can do. So we're supposed to write an equation, right? And the equation is y varies jointly as the square of x and the square root of z, and inversely as the cube of w. It just goes on and on, doesn't it? It's okay. You don't have to do it all at one time. You just break it down one thing at a time. So first of all, we know y varies. So we write y equals. We know we're going to have a k. Okay. Jointly, remember, means direct, and there's more than one thing. So jointly as the square of x, so that's x squared and the square root of z. So you can get my letters right this time. Okay. And inversely is the cube of w. Remember, inverse means to divide, and the cube of w is w to the third. Right? This is not bad at all. You've got this. Okay. Now, to find k, I've got to have a value for y, x squared, z, w, all of it. I've got to have a value. So x is 2. So I have k times 2 squared. Z is 25, so the square root of 25. W is 3, so I'm dividing by 3 to the third. Don't forget the exponents, okay? And y is 4, so 4 goes over here. And then I just simplify this as much as I possibly can. So it's k times 2 squared is 4. Square root of 25 is 5. 3 to the third is 27. So now I'm continuing up at the top. 4 is equal to, 4 times 5 is 20. K, it's okay to put the k in the back, over 27. That actually does not reduce. Now, what I'm going to have to do is multiply both sides by 27 and divide by 20. So essentially, this is what's going to happen on both sides, and that's going to give me k. I think everybody sees that. Now, I can simplify this fraction, or I can go right to my calculator, but 4 and 20 reduce to leave a 5 on the bottom. So k is 27 over 5. That doesn't reduce anymore. Now, I need this. That's not my answer, but I need it, right? My answer is the equation. It's y equals 27 x squared square root of z divided by w to the third. That's my final result right there. That's my equation. So I figured the more examples you have, the better you can do this. So it says write an equation describing the relationship. So y varies directly. Here we go with y and k. We always have that part. Varies directly means multiply as the cube of x. So k varies directly as the cube of x, x to the third. When x is 2, then y is 3. Okay, so that's the next thing. When x is 2, then y is 3. So we have 3 is equal to k 2 to the third. Okay. Now this extra part, remember, that's extra. My directions aren't right. Set up and solve. Okay, it says write an equation, but then it gives us extra stuff. So, you know what? I have conflicting directions here, because writing an equation goes to this point where you solve for k, and 3/8 is equal to k, and you plug back in, so y is equal to 3/8 x to the third. That's the equation. But when it has this extra stuff, find y when x is 4, maybe we're supposed to do both. So there's your equation. Okay, and then you find y when x is 4, so y is equal to 3/8 4 to the third. So y is equal to, okay, that's going to be 3/8 times 4 to the third is 4 times 4 is 16 times 4 is 64. Now I can simplify that and get 24. So that answers the last question. Just watch your directions, and I should probably just watch my directions too. I really didn't mean to give that quite like that. So this is another problem like we've already done, but the more you have, I think the better you feel about it. Y varies inversely, so y equals, you need a k. Inversely means you divide with the square of x, so x squared. When x is 4, y is 3, so you have 3 is equal to k over 4 squared. Now we're just quick at it, right? It gives me 3 is k is over 16. I solve for k. I multiply both sides by 16, so k is 48. Next we write the equation. So y is equal to 48 over x squared. So that's the equation. It didn't ask for the equation though. It asked to find y when x is 2. So y is equal to 48 over 2 squared. That's 48 divided by 4, and 48 divided by 4 is 12. So y is 12. Alright, so what happens when I turn this into a real story problem? Not just some words where we pick out the inverse or direct variation, but what if there's a big long application story that goes along with this? It's no different, okay? So it says the height of a ball bounces varies directly, can't read, is the height from which it was dropped. So the height of a ball bounces varies directly as the height from which it was dropped. A tennis ball dropped from 12 inches bounces 8.4 inches. From what height was the tennis ball dropped if it bounces 56 inches? Okay. Now, it may seem a little more confusing, but let's think about, first of all, we don't have any variables, right? So we've got to, this is our last problem. The illumination provided by a car's headlight varies inversely. Okay, so right here, varies inversely as the square of the distance of the headlight. Before we read any more, let's go ahead and write that down. Okay, we need some variables. So let's select variables. The illumination provided by a car's headlight, okay, varies inversely as the square of the distance. So I think we could use I for illumination or H for headlight if you like. And the square of the distance, let's let D be distance. So when I write my formula, I have I varies, there's my equals K. And it says varies inversely, so I'm dividing by the square of the distance. So that's D squared. You agree? Keep reading. A car's headlight produces an illumination of 3.75 foot candles. Now, foot candles is just a unit of measurement for illumination. Don't worry about that. I'm going to plug in 3.75 for my illumination. K is what we're trying to find. And D, it says, is distance of 40 feet. But remember, it was the square, so I've got to square it. I'm going to solve for K. First, by simplifying 40 squared. You really didn't have to calculate 40 squared. You could have just typed that in, but that is 1,600. And to solve, I'm going to have to multiply both sides of this equation by 1,600. So basically 1,600 times 3.75, and that's going to give me 6,000. So K is equal to 6,000. All right? So that's my constant of variation. This doesn't have units. So I have I is equal to 6,000 divided by D squared. That is my formula. Now it goes on to say, what is the illumination if the distance is 50 feet? So I'm calculating illumination. If I have 6,000 over 50 squared, I type that in my calculator, 6,000 divided by 50 squared gives me 2.4. Now, illumination wasn't in the units. Remember, it's those weird units, the foot candles. So this would be 2.4 foot candles is the illumination. I hope this helps you out. You have a great day.